right, looking at the notes packet, page 157, section 7.2, part 1. This is going to be a two-part section. We're looking at matrices. Now, you may have seen matrices in Algebra 2, but if not, we're going to look at what a matrix is and the different operations that you can use on a matrix in this section. So to start off with, a matrix is, it's called an array. So it's like a list of values. And similar to how when we were dividing polynomials, we had a synthetic division that only used the coefficients, a matrix is an array that only uses the coefficients of polynomials. So you can use a matrix to solve systems of equations. We're not going to do that in this section, but that's one of the uses for matrices. So when we're talking about a matrix, we say let m and n be positive integers, and then an m by n matrix is a rectangular array of m rows and n columns of real numbers. Okay, so, and this is a very theoretical definition. We could say that matrix A equals, now we always do row and then column. So this is the first row, and we'll go up to, we said m rows, and then columns, we have 1, 2, 3, 4, all the way up to n columns. So our first element, we'll call it a little a, is in the first row and the first column, so it's a11. This element here is a in the first row and the second column, a12. Now we don't usually say a sub 12, we would say a12 because the 1 and the 2 have different meanings. It's the first row and the second column. So then this would be a13, a14, all the way up to a1n. And now we're in the second row, so this is going to be a21, a22, a23, a24, all the way up to a2n, a31, a32, a33, a34, a3n, a41, a42, a43, a44, all the way up to a4n. And then we're going to skip down to the mth row. So am1, am2, am3, am4, and then we eventually get to our bottom corner, which is a sub mn. Okay. Now, instead of writing this whole thing out every time we're talking about a theoretical matrix, so if we don't have the actual values for the matrix, then we would use the shorthand. The brackets indicate that it's a matrix. We would use our variable, for this case it's a, and then I represents the row and j represents the column. So a sub ij. All right, so looking at example 1, in example 1, we're determining the order. Now, order is another word to mean the size or the dimensions. And it's always row by column. So in this first one, we have 2 rows and 3 columns, so this is a 2 by 3 matrix. All right, I'm going to leave the other 2 for you to label. Looking at our next objective, we want to be able to perform addition and subtraction, as well as scalar multiplication and multiplication. So I said them in the order that we're going to look at them instead of the order they're listed in the objective. But in order to add matrices, matrix addition is pretty straightforward. We're just adding each element. So notice for these 3 operations, your matrices have to have the same order. So they have to be the same size, okay? And in order to kind of make this more understandable, I'm going to use an example. We'll call A, matrix A, let's just say 3, 1, 2, 4. And then matrix B, we'll just say is 1, 0, 0, 5. Okay, those are just matrices that I made up. So if I want to add these two matrices, theoretically, I would say A plus B equals the matrix A sub ij, plus the matrix B sub ij, and we're going to add them element-wise, which means we add the first element to the first element, the second element to the second element. So we can write this in shorthand as A sub ij plus B sub ij. And what that looks like from our example is that we would have matrix A plus matrix B, and we would take the first element in each matrix, so kind of corresponding places in the matrix. 3 plus 1, 2 plus 0, 1 plus 0, 4 plus 5. So our resulting matrix would be 4, 2, 1, 9. Okay? The same thing goes for a difference. So if we're subtracting, then we're going to do the same thing. We would say matrix A minus matrix B is the elements in matrix A minus the elements in matrix B. And we can write that each element would just be piecewise or element-wise subtraction. How that looks in our example: 3, 2, 1, 4 minus 1, 0, 0, 5 equals 3 minus 1, first element, 2 minus 0, 1 minus 0, 4 minus 5 equals. Now, our order could not be negative. However, our elements can. So 3 minus 1 is 2, 2, 1, 4 minus 5 is negative 1. And that's okay. We can have negative numbers in our matrix. The reason when we define the matrix that they had to be positive integers is because we can't have an order that has a negative number. That doesn't make sense. I have negative 2 rows. That just, we don't talk about matrices that way. Okay, so then the last part on this page is scalar multiplication, which means I'm multiplying a constant by a matrix. So if I have a constant times matrix A, that would be that constant times each element, which I can write as K times A sub I J. In our example, let's let K equal, let's just say 5. Okay, so I have 5 times the matrix 3, 2, 1, 4, which means I'm taking 5 and multiplying it to each element, kind of like distributing. 5 times 3, 5 times 2, 5 times 1, 5 times 4 equals 15, 10, 5, 20. All right. All right. So we can actually use our calculator to calculate a lot of these with matrices. And in order to do that, we need to find where our calculator stores matrices. So kind of halfway down your calculator on the left-hand side, there's a little blue matrix, and that means we would have to go into second and then the inverse button in order to get into our matrix menu. Okay, so in order to get into our matrix menu, we went second and then the button that says X inverse in order to get into a matrix. Okay, and then within our matrix menu, the first menu that pops up is names, and now that's to actually use a matrix in a calculation. So if we hit the left arrow one time, this is where we create and edit our matrices. We're in the edit menu, and then you're going to hit enter to edit your first matrix. Now I already have one because I've used matrices before. If you don't have one, it would just be blank. So the first thing that we're going to enter is the order, and then we're going to put the elements in. So type the order. So you'll do M, enter, N, enter. Now remember, M and N are the size of your matrix, your number of rows and your number of columns. Okay, so in my example, I have a 3 by 4 matrix. So I do 3, 3, enter, 4, enter, and now I can type in the elements, which are, I'm just going to do the number and then enter for each element. And it's going to take you across the rows and then down to the next column. So the one on the screen, I would do 3, enter, and then -1, enter, 1, enter, -15, enter, and so on. Okay, and then in order to leave this, you have to do second quit. So second, and then the button says mode to use the quit feature. Okay, and that will take you back to your home screen. And then in order to use that, you would go back into the matrix menu, and you can either use the math part to do functions, which we haven't talked about yet, or just using the matrix and seeing what it looks like. All right, looking at example 2, we have this information about SAT scores, okay? And what we're looking for is the combined scores. Combined scores means we want to add. So we're looking for V plus M. Now remember, that's each element being added to the next. So I'll give you the first element and then I'll have you find the rest. So the first one, 508 plus 509, 508 plus 509 is 1017. So 1017 will be the first element. Go ahead and find the rest, pause the video, and then I'll show you the resulting matrix if you want to check your answer. Okay, so here's the answer to that question. And the way we would interpret this, for example, is the combined SAT score in Rhode Island in 2010. So Rhode Island in 2010 was 989. Okay, so we have a lot of data here displayed very succinctly, and that's one of the main uses for matrices. All right, on the next page, looking at example 3, we're looking at some retail prices. So if you go to the store to buy something, this is how much it would cost. It's a 3 by 2 matrix, right? 3 rows, 2 columns, okay? And then it says this city has a 7.25% sales tax, and we want to see what the price with tax would be. So recall that if you're adding tax to something, the cost is the price plus the tax. So really what we want to do is we want to multiply the matrix by 1 for the whole cost plus the 7.25%. So this is going to be 1.0725 times our matrix, 3.97, 3.78, 3.75, 3.64, 3.69, 3.67. I'm going to let you do that computation on your own, and you can check your answer with me if you have any questions. Okay, our last operation that we're going to talk about in this section is matrix multiplication. And this one is a little bit more complicated because the way we multiply matrices is not element by element, but rather we're multiplying the row by the column, so to speak. So the important thing to note here is that when we're multiplying matrices, the number of columns of the first matrix has to match the number of rows of the second matrix. And you're going to see why when we do a couple of examples. Okay? And theoretically, the way that we describe this is that each element in the product A times B is written as C sub ij equals AI1 times B1j plus AI2 times B2j plus all the way down to our last one, AIR times BRJ. Okay, that's going to make more sense when we look at some examples. Jumping into example 4, we find the product of AB, if possible, remember, because the number of columns of the first matrix has to match the number of rows. Okay, so the way that I remember how to do this is like writing a T. So I say this and this have to match. Okay, where the element that I'm finding is where, if I were to overlap these, where they would overlap. So in this first element right here where they overlap. Okay, so I'm writing AB equals, so in the first element, it's going to be 2 times 1 plus, then I move down 1, so 1 times 0 plus, and then the next one, negative 3 times 1. Okay, and then the next thing that I would look at is still that first row, but the second column. And those overlap the second element right there. Okay, so we're kind of looking at, if this is like the square, then this is like the triangle. So 2 times negative 4 plus the second part, 1 times 2 plus negative 3 times 0. So my box equals 2 plus 0 minus 3, which is negative 1. My triangle element equals negative 8 plus 2 plus 0, which is negative 6. And then we go on to the second row. So I'm going to use a different highlighter color here. So the second row here. And then again, our first column. We'll do an underline here. So this is, if I were to overlap my matrices, this is where they would overlap. So that tells me I'm in this element right here. 0 times 1 plus 1 times 0 plus 2 times 1. So this is 0 plus 0 plus 2 is 2. Okay, and then my last element, second column, second row, and we'll do a circle. Okay, so I have 0 times negative 4 plus 1 times 2 plus 2 times 0. So this, then this, and this, and they're all being added up. So my circle equals 0 plus 2 plus 0, which is just 2. So my resulting matrix is negative 1, negative 6, 2, 2. And that is my answer. Okay, and the last exercise for this lesson, we want to multiply these matrices, A times B. So I'm going to look across and down, Now this has 3 and this is 2, so there's no solution or undefined, because they have to be the same number of elements across and down, and they don't. Okay, so what I'd like you to do is think about what you learned this lesson and then write it in the box provided.